Okay, so hi, I'm David Lord. This is Testing with Knox and GitHub. You can find me at Davidism on Twitter, and these slides are on slides.com/Davidism. So these are two new tools I started using to run my tests, and I'm really enjoying using them. And I'm going to show you how I set up a project with Knox and GitHub Actions. And then hopefully you'll check them out and try them for your next project too. So Knox is a tool for running tests under different Python environments. The power comes from the use of a Python file for configuration. So Knox provides a clean, simple API for creating environments and running tests, but you also get the full power of Python to introspect and enhance that environment. You might be familiar with the similarly named Tox. Knox is the cool new alternative to that. GitHub Actions are a service provided by GitHub, surprise, to automate workflows when certain events happen. The workflow we're interested in is running our tests. The events we're interested in are when PRs are opened or committed to, and when we merge PRs back into main. You can use Actions to configure Windows, Linux, and Mac environments. There's some built-in essential actions, as well as a huge community of user-contributed actions for doing all sorts of automation. GitHub Actions has great integration with GitHub's interface, provides 10 simultaneous jobs, and in my experience, tends to start faster and run faster than other services I've used. So I'm really enjoying taking advantage of that for large projects. So let's combine Knox and Actions. Actions sets up the platform, then Knox sets up and runs the tests. Contributors can run Knox locally to see the same results that the automated tests will show on GitHub when they make their PR. So Knox executes knoxfile.py to get its configuration. Each test environment is defined as a function decorated with knox.session. Knox will set up a virtual environment for each session, and then we can use session.install to install requirements with pip. The dot here installs the project itself in the environment. The -r installs test requirements. Then session.run will run the given commands. We also get a little clever and pass session.postargs, which stands for positional arguments, and that'll pass any additional arguments you pass to Knox on to PyTest. So you can control all the little bells and whistles that PyTest gives you. So the fact that Knox configuration is Python code is what makes it so powerful. In comparison, Tox uses a text configuration, and while it can solve a lot of problems, it tends to get very verbose. And with Knox, you can introspect everything and run different commands in different cases. So in this example, I'm running across multiple Python versions, and then if I'm running on an old Python 2.7 system, I'm working around a bug with the requirements so that the tests will still pass until I can remove Python 2.7. And then I also have other environments such as running our style checks with pre-commit and building the docs. And when you run Knox, this is abbreviated, but it will run through each environment, create a virtual env, install your, we'll basically just go through all the steps you wrote in your code, show the output, and then you can see at the bottom it ran a bunch of different sessions, like all the different Python versions, our style, and our docs checks. So GitHub Actions are defined with a YAML file in this workflow will run on pushes and pull requests to main or version maintenance branches. That's what push, pull request, and then the different branch names here. So we're going to define one job called tests that runs a few steps. So just like Knox, jobs can run across multiple environments by defining a matrix. here we're defining the different Knox sessions that we're going to run against. And each session will check out the code, load pip requirements from cache so it goes faster, set up Knox correctly, and then run the specific Knox session. So we're running each Knox session in its own job so that tests run in parallel. And these are the results. So GitHub will run the workflow for each commit and shows the status of each test next to the commit or on the PR page. And you can dig into each job and the output of each step in case something failed. We could have run all the Knox sessions in one job, just like you would run locally, just typing Knox. But like I said, this allows us to run multiple jobs in parallel. This example that I've shown here just used one job for all the Python versions, though, for the test session. Since I put these slides together, GitHub has made a new config option that lets you parallel write the matrix a lot easier. So in my current code, I actually do run 5 jobs for 5 different Python interpreters. So everything runs in parallel. You can actually see that really quick if I can figure out how to go over here. So can you see my GitHub screen? David, thumbs up. Yeah. So over here we have running on Linux, Windows, and Mac, running the different styles and docs, and then also running the other supported Python versions. And that's all I've got for tonight. There are a lot more that Knox and GitHub Actions can do, way more than I can put into a talk. So I encourage you to check them out and try them in your own project. Flask and the other Palettes projects just switched to GitHub Actions, so you can check those out to see some live examples. Thank you.
Cool. Does anybody have any questions?
Oh, I guess I can still share.
I had a question if nobody else did. When Knox runs multiple Python interpreters, does it just sort of assume Python 2.7, Python 3.5, Python 3.6, Python 3.7 are somewhere in your path and will install a virtual environment for each one? Is that sort of how it works?
Yeah, it's just relying on virtualenv. So however virtualenv detects Python versions, it'll, here, let me see if I can find the example. So right here, where I say Python 3.8, 3.7, 3.6, those are strings that virtualenv would also recognize if you did virtualenv-p. There's all sorts of clever ways that it detects all that.
Cool. Any other questions? I don't want to monopolize it.
I don't really have chat.
I have a question. I saw on the output, David, that 3.5 was skipped. Was that because it couldn't find an interpreter to install in the virtual lab?
Oh, yeah, right here. Yeah, so I didn't have Python 3.5 installed on this machine when I ran it. So it just skipped that environment. There's a flag you can use to say, consider Python versions that aren't installed in error instead of a skip. But usually this is what you want, because when your contributors are running tests, they probably don't have like 6 different Python versions installed. And you don't want them to like wonder why their tests are failing.
Very cool. Thank you.
Yeah.